We're gonna show you the easiest way of understanding hematopoiesis. So suppose that this is a blood vessel, and inside the blood vessels are some of the cells that you'd expect to see in normal blood, like the red blood cells, platelets, which are just fragment of cells, and white blood cells. Even though all of these cells are found in the blood, they are actually not made there. Cells in the blood are made inside the bone. If you were to take a slice on it, and you look on it, you'd see that on the inside of the bone, there's a central cavity. The uncolored part is the hard part of the bone, and the colored part is the central cavity. Inside the cavity, there's the red spongy tissue. This stuff is called the red bone marrow. Bone marrow is where all of these blood cells are made. It's the site of the hematopoiesis. Hemato means blood. Poiesis means to form or to make. So hematopoiesis is the process of blood cell formation. Let's take a look at what goes on inside the bone marrow. What's interesting is that, as different as all of the blood cells are, they actually originate from the same cell. And that cell is called hematopoietic stem cell. These stem cells gives rise to all of the different cells that you see in the blood. It gives rise to two different cell lineages or two different cell groups.
All of the cells you see in the blood belong to either the common myeloid progenitor or the common lymphoid progenitor. The lymphoid group includes two different types of blood cells. First is the B cell. This cell has a nucleus that takes up the majority of the cell, and this cell is a B cell or B lymphocyte. It's very similar in appearance to the other type of lymphoid cell. When B lymphocyte enters the bloodstream, it becomes plasma cell. Plasma cells are specialized cell which produces antibodies known as immunoglobulin. Second is the T cell. The majority of the cell is taken up by the cell's nucleus, so that this cell has a nickname. It's often referred to as a naked nucleus. This is a T cell or T lymphocyte. What about the different types of myeloid cells? First is the erythrocyte. Its center is much lighter than its edges or the periphery of the cell. This is what we call pallor. RBCs don't have nuclei. It looks like a dumbbell if I showed you what the cell looks like on its side, where the edges are much thicker or much wider than the center. The edges, since they're thicker, they would be much more densely packed with hemoglobin. Since we know that hemoglobin is responsible of the RBC's red color, the edges would then be darker than the center. Since the center is much thinner, it would have a lot less hemoglobin. It would be a lot paler in comparison. Again, this cell is called an erythrocyte or red blood cell. What are some of the other types of myeloid cells? We have this one cell, a large and a very odd-looking cell, and this cell is called megakaryocyte. Even if you never heard of a megakaryocyte before, you may have heard of what it gives rise to because a megakaryocyte gives off a little blebs of its cytoplasm to form these small cell fragments called platelets. The rest of myeloid cells are actually different types of white blood cells. All of these WBCs are about twice the size of an RBC. This cell is called a monocyte. It's known for having a nucleus that's in the shape of a kidney bean. This is really a cool white blood cell because it protects us from bacteria and viruses and other invading organisms just like any other WBC does, but it does go in a very interesting way. Let's say that this was a bacterium. The monocyte would defend us against it. It would attack this bacterium by engulfing itself around the bacterium. It looks like it's eating the bacterium. Monocyte could form into a macrophage. Next, a cell that is broken up into several different pieces of segments. The segments are still held together by little pieces of string. This is called a multi-segmented nucleus. Even if you never heard of a neutrophil before, I'm sure you've seen them before, and how do I know that? It's because neutrophils are actually the main component of pus.
The major function of neutrophil is phagocytosis and destruction of foreign materials and microorganisms.
What are the other types of myeloid cells? Well, we have this one cell that's called a basophil. Its nucleus looks like a monocyte, except this cell has a very unique feature that the monocyte doesn't have, and that is, it has these bright blue granules in its cytoplasm that make it stick out.
Basophils appear in many specific kinds of inflammatory reactions, particularly those that cause allergic symptoms. Basophils contain anticoagulant heparin, which prevents blood from clotting too quickly. They also contain the vasodilator histamine, which promotes blood flow to tissues.
The last type of myeloid cell is an eosinophil. It has a nucleus that is sometimes found in two pieces, but this does not make the eosinophil unique. What is really well known for it is the fact that it has these bright, beautiful red granules in its cell cytoplasm.
Eosinophils regulate mast cell formation through the release of major basic protein called MBP. It destroys tissue-invading helminths and prevents reinfection. It is also a hallmark of allergic disorders.
It turns out that all of these cells don't directly develop from hematopoietic stem cell. Instead, they undergo multiple stages of development to mature into their adult form. But don't worry guys, we're not gonna hash out each of those different forms and their names and the physical characteristics. Instead, we're gonna make a very general statement. We're gonna say that the immature forms, all of these cells are called blasts. When the blasts mature, they are called cytes. Now, we can see here that what we said about that the immature forms being called blasts and the more mature form being called cytes is true. The T lymphocyte develops from the T lymphoblast just like an erythrocyte develops from an erythroblast and the megakaryocyte develops from a megakaryoblast. The only wrench I'm gonna throw into this pattern is with the neutrophil, basophil, and eosinophil, which all actually develop from the same cell, and that cell is called myeloblast. So I think that's a reasonable place to end our discussion on hematopoiesis.
This ends our discussion in hematopoiesis. Thank you very much.
Let's go! Wait! Ulitin mo! Ulitin mo!
Ano pa yun?
mo agad ha.
Blooper.
The most common. Most common. Ulit na lang.
Kunwari, maglo! Kakagulo ka dali! Hello!
Pwede naman i-video mo yung sarili mo ka ba?
Sorry na. May fan cam pala to. Na-amaze ako dun. Pero very big na talaga ang kamot. Ayusin mo. Ganunin mo kasi. Oh. Tapos, sana. Paano ba yun?